Hello everyone, I am Shaheed-ul-Islam, your digital friend for today physics video lecture from Scholar Arena. Today we will be covering the problems of chapter Newton's Laws of Motion Unit 2, particularly the topic of friction. We will do some advanced level selective problems on friction which connects many concepts of classical mechanics as well as some part of physics, which sometimes results in students getting confused while solving the problems. I will endeavor to make these problems as simple as possible and attempt to solve them in quicker manner. You know, in any competitive exam, especially NEET and JEE, space and time both are limited. Time pressure sometimes reduces the performance. It is also important to have command over the time and space management. Today we pick up 10 master questions here. Dear students, challenges are what make life interesting and overcoming them is what makes life meaningful. So keep on giving your best, stay with us and do subscribe to our channel. Share the link to your friends and help us reach every corner. Free education for all must reach to all NEET and JEE aspiring students. Let us begin our first questions. Everyone have a look over here. Questions here asked: a block is placed on a waist of mass m. What is the force exerted by the waist on the block? So here mg is the gravitational pull and normal reaction mg cos theta. If this angle is theta, then it is theta, and normal reaction is n. And you know, since this body is at static condition on the rough ways as shown in figure, the frictional force F mg sin theta, the component of gravitational force. So because of this mg sin theta, body has the tendency to move down, but friction always resists this relative motion. Since this body is at static condition, so body has no relative motion, but body has the tendency to move down. So therefore the friction here act along the inclined plane upward, and this F is equal to mg sin theta, and normal reaction to the inclined plane, that is normal reaction by the inclined plane on the body, is mg cos theta, and the force acting by the waves on the body, let us say it is F. This is F, neat force acting on the body. Sometimes in these problems, this is very good questions. In this problem, student may find the answer is mg cos theta, but mg cos theta is not the answer. Mg sin theta, it is actually along the inclined plane, so it is not the answer. And parallel to inclined plane, no question arises here parallel to inclined plane. So this is not the answer. Actually, the answer here, the neat force on the body, it is actually root over of n square plus f square, and this becomes mg. So mg is the right option here. So next questions. A 60 kg body is supposed to just enough force to start it moving across a floor, and the same force continues to act afterwards. The coefficient of static friction and sliding friction are 0.5 and 0.4 respectively. The acceleration of the body is. Here we must discuss the friction is a self adjusting self-adjusting force. Let us say body of 60 kg is placed here, and static friction, it is mu s is equal to 0.5 and mu k given here is 0.4. So maximum static friction mu s mg, this is normal reaction, this is mg, and static friction along this direction. If the body has the tendency, that is a force is continuously acting over it, and mu s mg, that is mu s is equal to 0.5 and this is 60 and this is 10. So the maximum static friction is 300 Newton. And kinetic friction similarly. Kinetic friction is equal to mu k mg, and mu k is equal to 0.4 and mass is 60 and this is 10. So therefore 240 Newton. If this force, since this force is variable force acting on the body, let us say when this force is 0, friction in this direction is also 0. If this force goes on increasing, it is 100 Newton, let us say. So friction is a self-adjusting force and imitate the magnitude of the applied force on the body. And friction here becomes 100 Newton. If this force is 200 Newton, so friction becomes 200 Newton. So friction is self-adjusting force as per the action given on the body. If this force is 300 Newton, so similarly we can say the friction is also 300 Newton. In this way, when the force acting on the body is just 300 Newton, so friction here becomes 300 Newton, and this friction is the maximum static friction. If this force is just, let us say if this force is 300.00001 Newton, so this force is slightly greater than the maximum static friction. Maximum static friction is 300. When this force slightly greater, 300.0001 Newton, so body start moving. When this body just starts moving, the friction becomes kinetic and this becomes 240 Newton. So this is why we can say the friction is a self-adjusting force. It is this friction, the magnitude of the friction imitates the magnitude of the force applied on the body. And it can adjust itself up to the maximum static friction 300 Newton. After that, if this force goes on increasing, body starts moving and the friction suddenly falls to 240 Newton, that is kinetic friction. So in this problem, 60 kg body is pushed. There are two friction, slight friction are static and slight friction are 0.5 and 0.4. So this is very interesting question also as before. Let us say this force is 300 0.0001 Newton. When this force slightly greater than the static friction, this friction becomes kinetic. It is as per this problem, it is 240 Newton. So body start with an acceleration A. So acceleration of the body into mass, that is net force, it is equal to, if I say F minus Fk, and this F is slightly greater than the static friction. So the value of F, starting from actually F max static friction, maximum static friction, and this is Fk, kinetic friction. So mass into acceleration, this is mu s mg and minus mu k mg. Acceleration here, that is initial acceleration, starting acceleration, when just body start moving with an acceleration A. It is actually becomes g mu s minus mu k, and mu s 0.5 and mu 4 is 0.4. So we can find the acceleration here. By default, if we take the value of g is 10, and this is 0.5 minus 0.1, so therefore the acceleration is 1 meter per second square. So in this type of problem, you just keep in mind that the initial acceleration always g mu s minus mu k. It is initial acceleration when body is under variable force, or the force acting on the body continues to act afterwards, and it is goes on increasing slightly. So just when the force is 300, the static friction becomes 300 Newton. And if this force is slightly greater than this, body just starts moving with an acceleration, and this acceleration is always A initial is equal to g mu s minus mu k. And just putting in the competitive exam, just putting these values, we can get the answer quickly. Next problem. A block of mass 0.4 kg is kept on the ground. The coefficient of friction between the ground and the block is 0.8. An external force of magnitude 30 Newton is applied parallel to the ground. The resultant force exerted by the ground on the block is. Here, force applied on the body is 30 Newton. So before calculating anything here, always we have to check what is the maximum static friction. Maximum static friction in this problem, or maximum static friction, is mu mg. Mu is equal to 0.4, and mass of the body is 0.4, and coefficient of friction is 0.8, and this is 10. So this is 3.2 Newton. I think this force is not 30 Newton, it is actually 3 Newton. This should be the 3 Newton. This force is not 30 Newton. It is actually 3 Newton. Since the force acting on the body, 3 Newton, is less than the static friction, less than the static maximum friction. So here friction is not at the condition of maximum static friction. This force is 3 newtons, so friction adjusts itself as per the action given on the body. You should keep in mind all time friction during the solving of problem based on the friction. Friction is a self-adjusting force. All time keep. So here friction is equal to 3 Newton. Since the maximum static friction is 3.2 Newton and the action given on the body is 3 Newton, so friction is not 3.2 Newton, it is actually 3 Newton. And normal reaction, it is equal to mg. And this normal reaction n equal to mg and value of m is 0.4 into 10, so therefore it is 4 Newton. The resultant force exerted by the ground on the block, friction and normal reaction, both are the contact force. Here body, there is no relative motion between ground and body, but still under this action body has the tendency to move. Since this body has the tendency to move, friction acts opposite to the tendency of the movement. So force given by the ground on the body, it is 3 Newton, and normal reaction on the body by the ground is 4 Newton. So resultant of these two contact force is R. So R is equal to root over f square plus n square. We can say root over, this is 3 square, 4 square is equal to 5 Newton. So next amazing problem. A block of mass 2 kg rests on a rough inclined plane making an angle of 30 degree with the horizontal. The coefficient of static friction between the block and plane is 0.075. The frictional force on the block is. Problem based on the inclined plane. The inclinations, let us say theta, and body is placed over it. Any problem based on the inclined plane, you just check the angle of friction. We know angle of friction, tan lambda is equal to mu. And lambda is equal to tan inverse mu, and this is tan inverse 3 by 4, and lambda is equal to 37 degree. This angle is 30 degree. Since the angle of inclination is less than the angle of friction, angle of friction is 37 degree and angle of inclination is 30 degree. So it is less than the angle of frictions. Actually, angle of repose is numerically equal to angle of friction. Angle of repose is what? Angle of repose is the maximum angle of inclination up to which a body kept on it can stay stationary. And angle of repose numerically equal to angle of friction. Since this angle is less than angle of friction, so here the friction acting on the body is not the maximum static friction. Here also you have to find out the force acting downward along the inclined plane. It is mg sine 30, and friction opposes any kinds of relative motion. But this body is not at the motion. This body is a static condition. Though this body is not moving, but the body has the tendency to move down because of the mg sine theta. And friction opposes the tendency of movement of the body downward. So friction acts upward. And numerically, this friction is equal to mg sine 30. Sometimes students may find the wrong answer immediately after going through the problem. The maximum static friction is equal to mu s mg cos theta. But this is not the answer. Actually, answer is mg sine theta. Mass given here is 2 kg and g I think 9.8, and sine 30 is equal to half, so therefore the friction acting is 9.8 Newton. So these are not the correct answer. Let us move ahead for next amazing problem on the board. A block of mass 1 kg lies on horizontal surface in a track. The coefficient of static friction between the block and the surface is 0.6 if the acceleration of the block is 5 meter per second inverse 2. The frictional force acting on the body is. A track is moving with an acceleration a is equal to 5 meter second inverse 2. A block of mass 1 kg is placed over the surface of the track, horizontal surface of the track. And you know, this body is placed on non-inertial frame. Non-inertial frame means the frame which is moving with an acceleration. When any frame is moving with an acceleration, the body kept on this surface and body kept on this frame experiences a pseudo force which is opposite to the acceleration of the frame. If the mass of this body is m, then this pseudo force is equal to mass into acceleration. That is the acceleration of the frame. Because of this pseudo force, body has the tendency to move in the backward directions or against the direction of the frame moving. But before solving to this problem, any type of problem based on the friction, all time, you have to check the maximum friction that can be offered by the ground that can be offered by the surface to the body. So let us check the maximum static friction. What is the maximum static friction? Maximum static friction, it is all time mu mg, and mu is given in the problem 0.61 into 10. So therefore this is 6 Newton. So maximum static friction is 6 Newton. Again we can say, because of this pseudo force, when this body has the tendency to move backward, this force is 1 into 5 and this is 5 Newton. So pseudo force acting on the body is 5 Newton, but maximum static friction is 6 Newton. Because of this pseudo force, when body has the tendency to move, friction resists the movement of the body, or the tendency acts against the tendency of the movement of the body because of this pseudo force. But this friction is not the maximum static friction. This friction is just equal to the force acting on the body, that is pseudo force, and the value of friction is, again, it is not 6 Newton, but it is 5 Newton. So answer is here is A. Right option matches here A. B, C, D are not the correct answer. Next, amazing questions. Here the problem asked, one body is placed 100 kg body connected by string over the pulley. The angle is 37 degree. The mass of this body is m. The question is asked, maximum value of mass for which 100 kg block remains in static equilibrium. Here the two types of questions sometimes asked. One question is, what is the maximum value of mass that can be hanged from the other end of the string? Or question may be asked also, what is the minimum mass required for this body remain at equilibrium condition? Here the question is asked is maximum value. Let us say the mass of this body is m and the weight or gravitational pull, that is mg, and you know tension xi from body and tension xi from body. Same string, same tension. Here 100 g sine 30, it is the component of the gravitational force. Since the question is asked what is the maximum mass, so let us say this mass is m, minimum mass. If this mass goes on increasing, so at a particular value of mass, this body has the tendency to move up. When this body has the tendency to move up, the friction acts on this body is F max is static friction. So maximum static friction here. Maximum static friction is equal to mu 100 g cos 37. Since the two body system are in equilibrium condition, so we can say mg equal to tension xi from body, and similarly tension xi from body placed on the inclined plane T. This is, since this body is at equilibrium condition, we can say T is equal to 100 g sine 37 plus mu 100 g cos 37. And on calculation, m equal to 137 means 3 by 5, and mu in this problem is 0.3. So this is 0.3, 100 into sine 37 is 4 by 5. So this is 60, and this is 60 plus 30 into 4 by 5. So 60 plus 24, and this value is 84 kg. So the maximum mass can be hanged from the other end of the string is, after calculation, it becomes 84 kg required. But here option A is 36, so this is not the answer. And option C 60 kg, this is also not the answer. And option D, it is 85 kg. 85 kg is not also the answer, because if we put here 85 kg mass, so total body start moving. This body start moving upward. So 85 is not the answer. So the maximum mass since it is 84, but there is no such answer is here, but here answer is 83 kg and our calculation gives 84 kg. We cannot put here 85 kg because if we put here 85 kg the total system starts moving. So right option here is B. So next, question 7. A body is placed on table and another body connected by the string passing over the pulley. Here there is no option given, A, B, C. 3 questions asked here. First question is what value of mu s would stop the block from sliding, and here one body is placed M1 and other body M2 connected by string passing over pulley. For the questions A, here the weight acting downward, this is M2G, and tension acts from body, and friction acts, since this body because of this tension has the tendency to move rightward, so friction acts against this tendency of movement, and this friction is maximum static friction. So since these two bodies are in equilibrium condition, so we can write here M2G equal to T. So force downward, force upward, so net force on this body is 0, and tension here is balanced by the maximum static friction. So this is maximum static friction S, and we know this is M2G and maximum static friction is equal to mu S M1G. So mu S is equal to M2 by M1. M2 in the problem it is 5 kg and M1 in the problem is 10 kg. So therefore the mu S, the value of coefficient of static friction is half. So this is 0.5. So if we want to resist the motion of this block or any relative motion of the blocks of the two body system, then the minimum static friction, coefficient of static friction should be equal to half. Next problem number 2. If the box is sliding and mu k is 0.2, what is the acceleration? So in the problem 2, the body is here M1 and body here is M2. Tension acts out from body, tension acts out from body. This is M2G. Since this body, the system of body are in moving condition and this body moving rightward, so the friction is here kinetic friction. The friction acting over this body is kinetic by the ground. Acceleration, if it is downward, then this body moves rightwards. Since these two bodies are connected by a string, inextensible string, so both bodies having the common acceleration. And acceleration A is equal to If we think that this two body as a whole system, so here the tension is a internal force. Tension is a internal force. M2G gravitational pull on the body, and here friction is also external force, and M2G friction both are the external force. We know friction is equal to net external force by total mass. So vector sum of force by scalar sum of masses. Vector sum of forces is equal to along the direction of acceleration, it is M2G, and against the direction of acceleration, kinetic friction by total mass m1 plus m2. So directly we can say, or we can write the equation of acceleration by just considering the two body as a single system, and T here is the internal forces acting on these two bodies, and M2G and friction, kinetic friction, are the external forces. So net external forces is M2G minus Fk. Here M2G you have to take it as a plus because it is along the direction of acceleration, and friction against the direction of acceleration, so you have to take here minus. So M2 here is 5 kg into 10, and this is mu k mg by 10 plus 5, and 50 mu k, the value of mu is given 0.2, this is 10 into g by 30. So therefore this is, this is not 30, it is equal to actually 15, and this is 50 minus 20 by 15. So the acceleration is 2 meter per second square. And the third question, what is the tension of the rope? Here in the case of tension, particularly for the competitive exam, you can use the superposition principle. Tension is internal force here. It has no contribution in the motion of two bodies. Tension actually we can write here, superposition principle, mass of right hand side, this is M2, and the force acting on the body, friction opposite to the tension, force acting on the body, friction opposite to the tension is equal to M2 Fk, mass of right hand side into force acting on the body against the tension on the left hand side body is Fk. Similarly, mass of left hand side, if we take the two side here, the mass m1 is taken as the left hand side and mass m2 is taken as a right hand side. So mass of the left hand side, the body, and force acting against the tension, force acting on this body against the tension is M2G by total mass. So therefore it is M2 mu M1G plus M1 M2G by M1 plus M2. If we take the M1 M2 by M1 M2, taking from the both the term of the numerator, it becomes 1 plus mu into G. So this is the tension. So for any two body system, when two body are connected by the simple inextinguishable massless string, and both the body are in the motion, then in this condition we can apply the superposition principle, that is the mass of the left hand side and force acting on the right hand side against the tension plus mass of right hand side, force acting on the body, against the tension by total mass. And putting the value here, it is 5 into 10 by 5 plus 10 and 1 plus 0.2. Since the body is in running condition, that is both the body are in moving condition, so we have to take here the friction is kinetic friction. This is not the static coefficient of friction, into 10. So therefore this is 50 by 15 into 12, and this is 50 by 3 into 4, 200 by 3 Newton. So this is the tension. This is the tension of the rope. So next exciting problem. Question number 8. Had the body is placed on a rough horizontal surface. The question is asked here the minimum possible force. The question is asked here minimum possible force by which the body can be moved. So before calculating this problem, so there is no such calculation in this problem. It is actually conceptual problem, or you can say this problem is painless problem. But before this, I have to discuss over the cases of pulling and pushing. Let us say one body is placed on a horizontal surface, rough horizontal surface, and pulling force is F at an angle theta. Here, because of the F cos theta component, body has the tendency to move forward and friction acts against the tendency of movement. Since the question is asked the minimum force required to move this body, so this friction is maximum static friction, and into two perpendicular component of F, one component F cos theta already written, and other component is F sin theta, and this is normal reaction, and mg is the gravitational pull. So this is actually pulling. The diagram illustration on the case of pulling. To move this body, F cos theta should be greater than equal to F max S, maximum static friction, and normal reaction here N equal to mg minus F cos theta, and you know, if we want to make the equation or want to find the amount of force required, then F cos theta, better to take it is equal to mu s n, and mu s is equal to mu s, and n here is equal to mg minus F cos theta. So pulling force equal to mu mg by cos theta plus mu, I should erase it because this is not F cos theta, it is actually F sin theta, and it is F sin theta, so mu sin theta. So this is the force, amount of force required to pull the body or to move the body. Similarly, in the case of pushing, force at an angle theta acting on the body with the horizontal. Here F also has the two component. It is one component is F cos theta, another component is F sin theta, and gravitational pull mg. So these are the forces acting on the body, normal reaction, upward, and friction against the direction of motion. Similarly, this is the clear two difference. The F sin theta, in the case of pulling, F sin theta acting upward, and in the case of pulling, F sin theta acts downward along the direction of mg. So F pushing, if we say F pushing, since this component only, F sin theta component becomes opposite in this case. So in this equation, mu mg can be written as cos theta minus mu sin theta. So all time it is not necessary to draw the forces and taking component, not necessary. If we know the pulling force, then automatically we can write the pushing force also. Here denominator cos theta plus mu sin theta, here denominator cos theta minus mu sin theta. So these two cases I have to analyze. One case is it is actually pulling forces acting at an angle theta. So A pull is equal to mu mg by cos theta plus mu sin theta. Similarly, in the case of pushing at an angle theta, F is the force, amount of force pushed the body. Here the F pushing is equal to mu mg by cos theta minus mu sin theta. So in the case of pull it is plus, and in the case of pushing it is minus. Obviously, pulling force is less than the pushing force. So this is why pulling is easier than the pushing. But you know, if any problem asked the angle given of the pulling force with the vertical alpha, similarly if the angle given in the case of pushing with the vertical is alpha, so it is not necessary to evaluate the pulling force and pushing force again. You just replace the theta 90, theta is equal to actually 90 minus alpha, theta is equal to here actually 90 minus alpha, theta 90 minus alpha, theta 90 minus alpha. So by simple calculation, it is mu mg cos 90 minus alpha, cos 90 minus alpha is equal to sin alpha, and this is mu cos alpha, and here mu mg sin alpha minus mu cos alpha. So my suggestions to my all dear students, you just practice or revision these two equations before any examinations. Directly write the pulling force or pushing force in terms of angle theta alpha, in terms of angle theta alpha. Theta is the angle with the horizontal, alpha is the angle with the vertical of the pulling or pushing forces. But I have to further illustrate here This pulling force is minimum when denominator cos theta plus mu sin theta is maximum. And you know, maximum differentiating this value d theta cos theta mu sin theta, we can say it is 0, because any maximum or minimum value cannot be differentiated here. So by principle of this maxima and minima, it is actually minus sin theta plus mu cos theta is equal to 0. So tan theta is equal to mu. So if this angle tan theta is equal to, if it is equal to mu, then we can say the pulling force is minimum. And you know, mu is also is equal to the tan lambda. So lambda is the angle of friction. So here theta is equal to angle of friction. So any body can be moved by the minimum effort if the angle with the horizontal of the pulling force is angle of frictions is equal to angle of friction. So any body can be moved by minimum of effort when the angle of pulling force with the horizontal is lambda. So pulling minimum, if we put here mu is equal to tan theta mg, and this is cos theta tan theta sin theta. So on simple trigo calculation, it becomes mg sin theta, or you can say also mg sin lambda. Since tan lambda is equal to mu, then we can say cos lambda is equal to 1 by root over of 1 plus mu square, and sin lambda is equal to mu by root over 1 plus mu square. You keep all time this formula. If tan lambda is equal to mu, then cos lambda is equal to 1 by root over 1 plus mu square, and sin lambda is equal to mu by root over 1 plus mu square. So minimum pull can be write as mg sin lambda, or you can say mg sin theta given in the problem. And this mg sin lambda can be replaced by mu mg by root over 1 plus mu square. So in our conception, or after illustration of the pulling and pushing two cases, all time you just keep this conception and apply it directly, this concept in the problem or any problem in the competitive examinations. All time the minimum possible effort to pull the body is all time it is d is equal to mg sin theta. So our next problem, what is the maximum value of F such the block shown in the arrangement does not move? Again, the problem is asked on the case of pushing. The previous problem was the case of pulling, you know. Here the pushing force, you have to find out the pushing force, the maximum value of force such that the block shown in the arrangement does not move. So for body does not move, that is the maximum force you can apply, you can apply it on the body, or you can push the body at the maximum value. And when question is asked the minimum value of force, sometimes question is asked minimum value of force required or pushing force is required to move the body. When question is asked to move the body, so it is minimum value, but when question is asked body does not move, then question is maximum value of pulling force. So directly in the competitive exam, since the time and space is very limited there, so directly without any deduction, pushing force without any deduction, pushing can be written as mu mg cos theta minus, as I told previous problem, it is cos theta minus mu sin theta, and the value of mu, it is given 1 by 2 root 3, and mass of the body is root 3, the value of z 10, cos theta cos 60, it is actually half, and value of mu is 1 by 2 root 3, and the value of sin 60 is equal to root 3 by 2, and it is 5, and 1 by 2 minus 1 by 4. So therefore the maximum pushing force can be applied on the body so that the body does not move. So C, B and D are not the correct option. So the right option matches here is 20 Newton, that is A. Next problem. On the board, the upper half of an inclined plane. So problem asked on the, again it is on inclined plane. That is an inclination having the alpha angle with horizontal. Here half of this inclined plane is smooth, that is mu 0, but rest half, that is lower half of the inclined plane, it is rough. So here mu not equal to 0, and here mu equal to 0. So this is the specific problem asked. Half of the inclined plane is smooth and half of the inclined plane is rough. But I will consider here inclination alpha, some part of this, that is upper part, let us say this part is smooth and lower part it is rough. One body starting from the top, the problem actually is like this. One body is starting from top and body attains some velocity here, let us say it is v, and finally the velocity of the particle becomes 0 at the bottom of the inclined plane. So from the simple equation we can say body starting from rest, so v square is equal to 0. It is starting from rest, since it is starting from rest, and acceleration, let us say in this part is twice a1 s1 and path length is s1. Similarly, at the bottom of the inclined plane the final velocity becomes 0, but initial velocity in this point is v square, and since here in this part the velocity decreases and finally becomes 0, so in this part certainly it is retardation. So therefore this is a2 and path length is, I have taken there s2. So v square is equal to twice a2 into s2. we can say from these two equations, twice a1 s1 and this is equal to twice a2 s2. a1 is the acceleration in the smooth part and a2 is the retardation in the through the rough surface of the inclined plane. And a2 by a1, if we write, then it is s1 by s2. Since in this part the body velocity of the body goes on decreasing and finally becomes 0, so in this part retardation and in this part acceleration. Retardation here mu g cos theta because of the friction minus g sin theta because of the gravitation in the rough part of the inclined plane, and acceleration a1 in the smooth surface is equal to g sin theta due to gravity, and this is actually s1 by s2. And by simplifying this, it is mu cot theta minus 1 s1 by s2. So mu cot theta is equal to s1 plus s2 by s2. So mu cot theta is equal to total path length by s2 is the path length of the rough surface. So if we take this formula, it's an advanced formula, mu cot theta s1 plus s2 by s2. So total path in this problem, it is specific problem because half of this path is smooth and half of this path is rough. But sometimes question may not be given on these specific situations. Path length may be given anything like this. Here the ratio of the path length is 1:1, but sometimes the path length ratio may not be the 1:1. It may be 2:1, 1:3, 3:1, anything like this. So directly apply this formula, particular in this type of problem. Mu cot theta is equal to total path length by path length of rough surface. So if we put here mu cot theta and this is 2s by s, so I think mu cot theta is equal to 2. So after going through the option here, mu is equal to sine theta or alpha, whatever may be the theta or alpha, whatever may be the guy going through this option, you know, mu sine theta, mu is equal to sine theta, it is not the correct option. B, mu is equal to cot theta is also not the correct option, and mu is equal to 2 cos theta is also wrong answer. So here we can say mu is equal to 2 tan theta. Here just I am applying, you know, half of the path is smooth and half of the path is rough, so therefore it is 2s and it is s, 1:1 ratio, so mu is equal to 2 tan theta. So I hope in this way all the problem what I have discussed today getting clear to all of you. So best wishes to all of you. That's all.